Namaste. Welcome to the next video of Machine Learning Practice course. In this video, we'll discuss the remaining steps of end-to-end machine learning project. We'll begin by discussing the step that involves fine-tuning of machine learning model. Usually there are a number of hyperparameters in machine learning models which are set manually by the machine learning model developer. Tuning these hyperparameters usually lead to better accuracy of machine learning models. However, finding the best combination of hyperparameters in a brute force manner is a challenging task. The hyperparameter space is huge and finding the best combination is a search problem in this huge parameter space. Fortunately, we have a couple of ways in which we can perform this activity in scikit-learn package. The first one is the grid search. We have a class grid search CV that helps us in finding the best combination of hyperparameters. We can import the grid search CV from model selection package. We need to specify a list of hyperparameters along with the range of values to try. Once we specify these values, grid search CV would automatically evaluate all possible combinations of hyperparameters using cross-validation. Let's take a concrete example of performing hyperparameter search in random forest regression problem. There are a number of hyperparameters in random forest regression, such as number of estimators, maximum number of features. So we specify the parameter grid or the combinations of parameters to try in form of a parameter grid. In this case, we specify number of estimators to try to be a list of three numbers 3, 10 and 30. And maximum features that we want to try is 2, 4, 6 and 8. We also specify the value of bootstrap to be false and the number of estimator to be 3 and 10 and maximum features to be 2, 3 and 4. So we specify here two sets of hyperparameter search problems. There are two combinations. The first combination contains number of estimators with 3 values and maximum features with 4 values, and the second combination has an additional bootstrap parameter which is set to false. Let's compute the total number of combinations that will be evaluated here. The first one has 3 values for number of estimators and 4 values for maximum number of parameters. That would lead to 12 combinations. And the second one has 2 values of number of estimators, 3 values of maximum features, thus resulting into 6 combinations. So the total number of combinations that will be evaluated by the parameter grid is the sum of these two combinations, which is 12 plus 6, leading to 18 combinations. Let's create a grid search CV object with the parameter grid. In grid search CV, we specify the estimator, which is forest_reg. This is the random forest regressor object, the parameter grid, number of cross-validation fold, the scoring scheme, and a flag that specifies whether we want to also return the training scores. So we need to train this model for 18 parameter combination, and each combination would be trained 5 times because the number of cross-validation is set to 5. So in all, we'll be performing 90 model training runs. So we can launch the hyperparameter search by calling fit function on the grid search CV. Once the fit is complete, we get the best combination of hyperparameter with the best underscore parameter underscore member variable of the object. Here the best combination of parameter seems to be maximum features equal to 6 and number of estimators equal to 30. Let us find out errors at different parameter setting. We can find that out with CV underscore result underscore member variable. And you can see that these are the mean squared error, and this is the combination of hyperparameters. So in the first row, you can see that the maximum number of features to be used is 2 and number of estimators to try is 3. In this setup, we get mean squared error of 0.5. And you can see that there are these 18 combinations that we have listed over here, and for each of these combination we have specified what is exactly the value of the hyperparameters that were tried and what is the mean squared error. And you can see that the best mean squared error or the least mean squared error is obtained for a combination of parameter where max feature equal to 6 and number of estimator equal to 30, and that value is 0.352. So this is the best parameter, this is the best parameter setting that was obtained with the grid search. We can obtain the best parameter, we can obtain the best estimator with best underscore estimator underscore member variable of the grid search object. And you can see that in this best estimator, maximum features is equal to set to 6 and number of estimator is set to 30, and this was the combination that was obtained with grid search CV. In this case, we have initialized the grid search CV with 3 fit equal to true option. When we set 3 fit equal to true, the grid search CV retrains the best estimator on the full training set. This is likely to lead us to a better model as it is trained on a larger data set. The second option that is provided by the sklearn package is randomized search. When we have a large parameter space, grid search CV can be inefficient. In that case, it is desirable to try randomized search CV class. Randomized search CV class selects a random value for each hyperparameter at the start of each iteration, and then it repeats the process for the given number of random combinations. It enables us to search hyperparameter space with appropriate budget control. So we can import the randomized search CV class from model selection. The analysis of model provides useful insights about the feature. Let's obtain the feature importance as learned by the model. So with grid search, we know that the best estimator can be obtained with best underscore estimator underscore member variable. We can obtain the feature importance by calling the member variable of this best estimator. Here you can see the feature importance of each of the variable, and we have listed the feature importance in the descending order of the importance. So the wine quality is highly dependent on the alcohol, or the alcohol feature is the most important feature in determining the wine quality, and it has got score of 0.24, followed by sulfate, volatile acidity, followed by total sulfur dioxide, density, and so on. Based on this information, we may drop a few features that are not so important in prediction of the target variable. And based on the reduced feature set, we again retrain the model and follow the process. We retrain the model, we find the best combination of the hyperparameters using either grid search CV or randomized search CV depending on depending on the size of the parameter space. And once we obtain the best parameter, we can analyze that model and find the insights about the features that are important. It may also be useful to analyze the errors made by the model in prediction and understand its causes. This helps us in getting useful insights, and maybe we can go back to the domain experts and consult if we can add better features to stem those errors. So you can see that this machine learning model development is totally an iterative process. We start with some feature set and then we train the model, we perform the hyperparameter search, and then we analyze the model. We understand the feature importance and also look at the errors in the model. Based on the errors, we go back to the experts, consult them, find out how to take care of the error. In order to take care of the error, we might need a new set of features or some kind of a feature transformation of the existing features. We perform that and we again go back and retrain the model. And this process continues until we get the model of the satisfactory quality. And once we are happy with the model performance, once we are happy with the model that we obtained, we evaluate its performance on the test set. Remember, we always report the performance of the model on the test set, because ultimately the model has to work well, it has to generalize well on the unseen data. Hence, the performance of the model is reported on the test set. While evaluating the performance of the model on the test set, we need to make sure that the transformations that were applied on the training set are uniformly applied to the test set. Here, we make use of the pipeline class for making sure that the transformations are applied uniformly across both the training and the test set. So we use the fit transform method of the pipeline object on the test set, and we obtain the transform version of the test set. We use this transform version and call the predict method on the best estimator obtained through the grid search or through the randomized search. And this predict method returns the predictions on the test set. Based on these predictions, we compare these predictions with the actual predictions and calculate the mean squared error or any other appropriate metric based on the model at hand. In this case, we get mean squared error of 0.35. It is a good idea to get 95% confidence interval of the evaluation metric. It can be obtained by using stats class from SciPy. We get the 95% confidence interval with stats.t.interval by specifying the confidence interval. And the confidence interval, 95% confidence interval for mean squared error in this case is between 0.29 and 0.41. Once we have a reasonable model based on its performance on the test set, we reach the pre-launch phase. Before launch, we need to present our solution that highlights learning, assumptions, and system limitations to the group of our collaborator. As we discussed earlier, machine learning model development is a collaborative activity between the model developer, domain experts, and product teams. We need to document everything, create clear visualizations, and we should present our model. In case the model does not work better than the experts, it may still be a good idea to launch it. This will help us in freeing up precious bandwidth of the human experts. And the final step in the process is the launch step. In launch, we plug in the input sources and write test cases to make sure that the model works well end to end. Writing test cases is quite crucial because it gives us more confidence about working of different pieces together. And once the model is launched, we need to monitor it closely. We need to monitor for the system outages, find ways to mitigate those outages or minimize those outages. While monitoring the model, if we found that the model performance has degraded, we need to have a strategy to tackle that situation. The situation can be tackled either by retraining the model, and this retraining can be scheduled after some kind of a fixed time. We can retrain the model, let's say, in every 2 weeks, or whenever we see a drop in model performance by some kind of a threshold metric, then we can launch the retraining of the model. So for that, we need to first fix what is the threshold on the metric, and once that threshold is breached or once that threshold is crossed, model performance, once that threshold is crossed, we need to trigger the retraining of the model. Another important thing to evaluate the model performance is to sample predictions for human evaluation. We can present the predictions by the model in production to the human experts and get their feedback on how model is performing. We also need to carry out regular assessment of the data quality, which is critical for model performance. Remember, the model performance depends on the feature values, and if features are not getting captured correctly, it will adversely affect the model performance. And the readings that and the output that we get from the model, if we consume in the downstream tasks, there could be effect that are undesirable. Finally, model maintenance. We can either train the model regularly in every fixed interval with fresh data, or we can also trigger the model retraining based on some kind of a threshold in the degradation of model performance. And we should also figure out how to push the trained model to production without disrupting the live path of the serving. So these were the 8 steps involved in end-to-end machine learning project. So I hope you have a better clarity about steps that are involved in machine learning project. I request you to follow this advice meticulously in the subsequent classes or in subsequent sessions of this particular course, and also you should carry this advice into your working. So if you follow this advice rigorously, you will be able to build machine learning models of high quality, and you will be a successful machine learning developer. I hope you enjoyed this content, and in the next from the next class we'll start talking about mechanics of sklearn library. We start with high level introduction to sklearn library, and we will deep dive into different machine learning algorithms and their implementations with sklearn library. Namaste.